In this problem, we're supposed to, again, find extrema for the original function and use the second derivative test to do that. And then we are supposed to find y values, ordered pairs. So once we get the x values, all that means is we'll have to plug each one back into the original function to get the y value that goes with it. So, to get the critical numbers, we need to set the first derivative equal to 0 and also find out where the first derivative doesn't exist. This is already factored, and I can tell you that the first factor, e to the x, is never going to equal 0, because no matter what you put in for x, even if it's a negative number, you'll still have 1 over something. You'll still be above 0. You'll still be positive. X plus 1 is the other factor. Obviously, when that's set equal to 0, you get negative 1. So plugging this one and only critical number into the second derivative, you know what, I'm just going to be a little lazy here. I'm going to call it y double prime of negative 1. Would give you e to the negative first times negative 1 plus 2, which is 1. Well, e to the negative first is 1 over e is positive. What that means is that our graph is concave up when x is negative 1. Concave up would imply you have a minimum value if you have any extreme. So we can say, oh, then we got to plug the negative 1 back into the original. So plugging negative 1 into the original function gives you negative 1 times e to the negative first, negative 1 over e for your y value. So our final answer would be negative 1 comma negative 1 over e is a relative min for y, because y prime of negative 1 is 0 and y double prime of negative 1 is positive.